Alright, so for my problem this week, I had number 58, which gave us two parallel plates, and it's got a voltage across it of 200 volts, and these plates are separated by 1 centimeter. Now they're shooting an electron at V equals 1 times 10 to the 7th meters per second, and they want us to find the B field so that it goes through undeflected. So if we go in here and add our E field lines, they go from positive to negative, like so. Now the first thing I start out doing is saying that we know V equals E times D. And we need to find E, because we know V and we know D. So we say E equals V over D, which is equal to 200 volts over 0.01 meters. Now this is equal to 20,000 volts per meter. Now that we have found E, we can say F equals QE and multiply 1.6 times 10 to the negative 19th coulombs, the charge of an electron, or a proton rather, times this 20,000 volts per meter. And now that number brings us to 3.2 times 10 to the negative 15th newtons. Alright, so now we take our new formula we found this last week and say F equals Q times V cross B. Now we know from the right hand rule, if it's going to be undeflected, there's going to be a force either up or down. And since V is going straight across, if the force is up or down, if V is going to the right, and we want to move it up, then B field would be in. If we want to move it down, then the B field would be out of the page. Alright, so we know that that cross product is going to give us a sine of 90, so we can just simplify that to Q, or F equals Q V B. Alright, now we can say F is equal to 3.2 times 10 to the negative 15th newtons, because that's the force created earlier by the E field. And now we want to negate that with this B field, so we say that that is equal to Q, which is 1.6 times 10 to the negative 19th coulombs, times V, which is 1 times 10 to the 7th meters per second, times B. Alright, and then you just do a little bit of algebra, isolate for B, you get B equals 0.002 Tesla, or 2 millitesla. Alright, now for the topic of into or out of the page, how I started it was I immediately flipped this to saying an electron moving to the right is equal and opposite to a proton moving to the left. Alright, so let's use the right hand rule here. So we've got V, the positive charge, moving to the left. Now, based off this E field, and the plus charges on top are going to want to repel this proton, so they're going to want to push it down. So natural force on the proton here is pushing it down, and we want to negate that and push it up. So if we want the force up, we have the velocity this way. So we've got velocity with the forefinger. The thumb is pointing up in direction of the force, which means that our B field will be my middle finger, which is pointing out of the page at you. Now this is for a positive charge.